Alright, so hello grade 10. So welcome back to our YouTube channel and let's have a review about linear permutation. Okay, I know it was discussed already on our third quarter, di ba? Pero balikan natin yung concept about linear permutation kasi nako-cover niya lahat ng permutation. Okay? Mahirapan kayo intindihin yung mga circular and the distinct permutation without understanding the linear permutation. Okay? So, as I have said, linear permutation covers all the permutation. Kaya di ba kanina yung pinaka-formula or sa previous video bago to, yung pinaka-formula natin ng permutation, yun yung linear permutation, which is the permutation of n objects taken r at a time is equal to n factorial over n minus r factorial. Okay? So, yun yung formula natin for linear permutation. And yung mga word na tatandaan natin, kung kailan ba natin ginagamit yung formula na to, is yung word na, yung mga keyword na linear or line up, or wherein meron tayong arrangement na binubuo na kailangan naka-line up sila, can be horizontally, vertically. Okay, so there is a word of row. May mga row na makikita tayo dyan. And also the ranking of the position. Okay. Yan, yung mga keyword natin for the linear permutation. Ngayon, ipakita natin paano nga ba na-derive yung formula natin na to. Okay. I know, naturo ko na to sa face-to-face, pero balikan lang natin. So, let's say, meron tayong 5 students. Si student A, si student B, student C, student D, and student E. And we have here 5 chairs. Okay, so nawala ako at pumasok yung pamangkin ko. Sorry for that. Again, balikan lang natin. Meron tayong student A, student B, student C, student D, and student E. And we have to arrange these 5 students in a 5 chairs. Okay, meron tayong 5 available chairs. Chair number 1, chair number 2, chair number 3, chair number 4, and chair number 5. Okay. Ngayon, we are going to list down the choices or the options that we have. Yun naman kasi yung concept natin about sa permutation. Ilang scenario, ilang arrangement ba yung mabubuo natin? Okay. So, sa chair number 1, ilang options yung meron tayo dito na pwedeng makaupo? Okay. How many choices do we have to be seated on chair number 1? We have 5. Di ba pwedeng lahat sila pinagpipilian natin na pwedeng umupo sa chair number 1. Okay, how about the chair number 2? Okay, kung si student A umupo na dito sa chair number 1, ilang options na lang yung meron tayo? We have 4. Okay, pwedeng itong 4 na lang yung choices na pwedeng umupo dito kasi umupo na si student A sa chair number 1. And sa chair number 3, we have 3, 2, and 1. And by applying the fundamental counting principle, wherein we are getting the product of our choices or our options. Yun yung concept about the FCP. Okay, kinukuha natin or pinagmumultiply natin yung mga choices na meron tayo. So, 5 times 4 times 3 times 2, 5 times 4, that is 20, times 3, 60, times 2 is 120, times 1 is 120. So, ibig sabihin, we have 120 ways we can create in this, or meron tayong 120 scenario na mabubuo dito. Okay? So, ano-ano ba yun? Medyo marami kung ililista natin yung 120. Pwede yung A, B, C, D, E, pwedeng E, D, C, B, A, or marami yan. Okay? So, one thing interesting about this, what if meron tayong 3 chairs? Okay, chair number 1, chair number 2, and chair number 3. And we have here 5 choices or 5 options. Okay? Or 5 students na pwedeng umupo dito sa 3 chairs. So, gawin natin yung ginawa natin dito. Okay, the difference is binawasan natin ng 2 chairs. 3 na lang. Okay, sa chair number 1, ilang options ang pinagpipilian natin? We have 5. Okay, lahat sila si student A, B, C, D, and E. How about chair number 2? We have 4. And for chair number 3, we have 3. And again, applying the FCP or the fundamental counting principle, that is 5 times 4 is 20 times 3, that is 60. We have 60 ways. Okay, what we just did on our first scenario is we had n factorial. Tama? Kung ang n natin is equal to 5, if our n is equal to 5, what we just did is 5 factorial. Di ba ang 5 factorial is equal to 5 times 4 times 3 times 2 times 1. Ganun yung ginawa natin sa first scenario. Okay. Next, sa chair number 2, sa scenario number 2, ganun din naman. Kinuha din natin yung n factorial. Tama? Pero ang kinaibahan, hindi natin siya tinuloy sa 2 and 1. Kumbaga, tinanggal natin si 2 and 1. Kung ipapakita natin yun, meron tayong 5 times 4 times 3 times 2 times 1. So, sabi natin, hindi tayo tumuloy sa 2 and 1. So, kinancel natin siya. So, kailan ba natin dapat i-cancel to? Kailangan meron siya sa denominator na 2. Okay? Kumbaga, 5 minus 3 factorial. Okay? So, pwedeng kapag sinimplify natin to or pinakita natin to, 5 times 4 times 3 times 2 times 1 over 5 minus 3 is 2 factorial. That is 2 times 1. So, na-cancel yun. Doon nabuo si 60. Okay? So, 5 times 4 times 3, that is 60. So, we have 60 ways. Kumbaga, dito sa second scenario natin, yung n natin is the total number of options na meron tayo, which is 5. Okay, then yung r natin, if we are going to apply the formula, permutation of n objects taken r at a time, yung available na chairs na meron tayo, which is 3. Okay, so dito, pumapasok yung formula natin, okay, na n factorial over n minus r factorial. No, so, kung gagamitin natin to, that is 5 factorial over 5 minus 3 factorial of, which is equal to 5 factorial over 2 factorial, which is equal to 60 ways. So, I hope you understood what is the concept about the linear permutation. Okay, let's try 2 example about linear permutation.